In this next lesson, we're going to look at a different type of exponent, but let's recall the basics of the exponents we know so far. We have what's called the base, and then we have an exponent, but in this case, we can use m will be our exponent. But what if we now have a rational number as an exponent? So our exponent is a fraction, like this over here. The n as the denominator in the exponent is called the root. So let's look at what happens when we have a rational number exponent. Well, think about if we had the number 25 squared. This would mean 25 times 25. So we're taking two of those. But let's compare that to now half. Well, 25 to the power of 1 is just 25. So if we have half of an exponent, half of 1 for an exponent, it would make sense that our value of this is going to be smaller than 25. So what we do here, 25 to the power of 1/2, is we look at how this is actually means we're taking the square root. The 2 is the denominator. And this is what goes here. Well, this symbol here is called the radicand. It is a square root symbol, but only because we're finding the square root, and we know that because it's a 2 here. But this would mean that 25 to the power of 1/2 equals 5, because we're taking the square root of 25, which is 5. Now, we need to make sure that we rewrite this with the radicand. And if we want to actually evaluate it, so give it its actual value, then we will write it as 5. But this is what we're going to practice first, just going from our rational exponent term and to rewriting the expression using a radicand. So let's do some more vocabulary quickly. In the case that you have this, you're going to rewrite it as this is called a radicand. You will rewrite it with your base number in the radicand, your m value in parentheses will be the exponent, the top exponent outside of the parentheses, and your n value is the root that you are finding of your base. So for example, let's do another example. If we have x to the power of 3 over 2, we would rewrite that as we put our 2 here, our radicand, our base, and our exponent. Root next to the radicand. This tells us what power, what root we're finding. We're finding the square root in this case. The exponent is outside the parentheses, and the base is in the radicand. We didn't use parentheses here, but we can. We would just be putting the 1 outside. We didn't use it because it's not changing anything. This power of 1 means that it's just the square root of 25. So anytime your root is different than a 2, you need to include the parentheses and the number, I'm sorry, not the root. The exponent is anything other than 1, such as here being a 3. you need to include it with parentheses outside of the radicand form. Okay, so let's go over here and evaluate these before you do some practice. So we already did this one. Let's look at 27 to the power of 1/3. That's equal to radicand of 27, and we're taking the cubed root in this case. We could also write it like that, but we don't really need that part because, like I said, the exponent is just a 1, and so it's just cubed root. Okay, let's look at 16 to the power of 1/4. Radicand 16, 4 is the root that we're finding. And then we don't need to put the parentheses in the 1, but we could. Now think about what this means. We're thinking, what number was multiplied 3 times to get 27? Well, 3 times 3 is 9, times 3 again is 27. So if we were to evaluate this expression, the answer would be 3. The cubed root of 27 is 3. Look here. What number was multiplied times itself 4 times to get 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. So our root, our radicand, our root 4 of 16 would equal 2 if we were to evaluate it. But we really only need to rewrite our exponents for now with a radicand symbol. And we do that when we have rational number exponents or fraction exponents.